Hello everyone, welcome to this session of serverless application with AWS step functions. So today we are going to talk about how to develop serverless applications using step functions. My name is Rajesh Bhojwani and I am a solution architect. I've been working on AWS since last 6 months and I've been playing around with Lambda functions and step functions. So I will be sharing my learning on this topic. So we have been building applications using Lambda functions for a while. But what I found is that there are many use cases which are still difficult to be implemented using Lambda function. The reason being is that Lambda comes up with a lot of limitations as well. I've written a blog around it and even the video also. You can go and watch about it, where I talked about what all the limitation it has and what all the best practices are around Lambda function. So come to this topic. If you want to develop applications where you have sequence of events or sequence of tasks to implement, you can do that using Lambda function. But if you need to orchestrate all those steps or the tasks, then it is a tedious job. And that's the reason it's not easy to do that with plain vanilla Lambda implementation. If we talk about the another use cases, let's suppose you want to run the task in parallel and then you want to use the outcome of those parallel tasks to fill into the another task and then execute it. That is something also is very difficult if you don't have any orchestration system around it which can collaborate all the inputs and output and coordinate it with all those tasks. So let's assume that we are running a sequence of tasks or parallel task in Lambda or any other activity worker. What if those tasks started failing? Maybe it is a temporary reason that the downstream system is not ready or some system network glitch. Most of the cases can be resolved by just retrying that call to the third party service or to the downstream service. And that's the way you would need the retry feature, which is right now missing in Lambda. You have to do it by your own. Now let's take another scenario where you execute a task and based on the output of that execution, you want to take action A or action B depending on the data value. That is something is not available as a built-in feature as of now in Lambda function. Now let's talk about one of the most common scenario where people started using Lambda function is for the batch job. Now we know that Lambda has a maximum execution time allowed is 15 minutes. So if you have a batch job which needs to run more than 15 minutes, then you cannot do well with the Lambda. And the kind of data we have now in the system, it needs more and more execution time. So that is something we cannot do it in Lambda because of the 15 minutes of limitation. Now what if I want to do the error handling in my functions? If I want to put try, catch and finally block, handle the exception and then pass that error to the next step, how do I do it? There's no feature right now available in Lambda for handling that stuff. And that's the reason we need the solution around all those scenarios. Some of the possible solution would be like the first one is function chaining, which I sort of talk about it while telling you the limitations of lambda function. That if you want to use this sequence of tasks to do, then you have to do function chaining, calling one lambda function from another lambda function. But suppose some of the lambda function gets failed, the
Second
chain is
option we
broken,
have is
then how do we
to
handle it? That
orchestrate
solution is not
tasks
available
functions
right now.
using the persistent storage like AWS database.
Now, what we can do is that the lambda function, which are generally stateless, and they can store the output of each function on the database, and the another function can read from there and then execute its steps. But the problem with this solution is that the RDBMS DBs are not generally scalable. So it's very difficult to scale your application while using this solution. One more solution which resolves the scalability issue is by using the queues. The one lambda function can put the messages into the queue, another can read from there. But again, the same challenge will still be there, that there is no orchestration readily available. So we have to build the error handling mechanism. We have to do retry logic, and we need to find a easy way to pass the output of one lambda function to another one. If you want to do filtering of those output data, then it is very difficult. I'm not saying it is not doable, but it will be a tedious and it will be difficult to maintain those kind of logic in this solution.